introduce all that in a little bit. So we're going to take the next about 45 minutes here and talk about how to get started. So we have someone who has not been introduced to you yet, who stands head and shoulders above me in intelligence and capability. This is Brandon. Brandon, why don't you introduce yourself?
Yeah, hey everybody, thanks for coming. My name is Brandon. I'm Concurrency's lead data scientist, and I've been doing applied math for about 8 years, building the machine learning systems that Nathan and team have talked about earlier today. It's great to meet everybody.
Awesome. So we're going to break this presentation up into a couple different sections. I'll kick it off, then Brandon's going to take the ball, and then Brian's going to cover some really getting into the weeds and some of the things that Tim talked about, and then we'll hand it back to Brandon. So, all right. So I think that this is probably the thing I want you to remember from this session. It's also how we can help you, but it's really about where you are on a particular journey. And any one of your organizations is going to exist somewhere on this journey, or maybe even multiple places on the journey simultaneously because of the way your organization is structured. So we've worked with companies all the way up to Johnson Controls and all the way down to ones that only have a few 100 million of revenue production, right? So that's a pretty big range, right? We've done the envisioning sessions for Johnson Controls, Generac, and then down into smaller companies, right? So that's a very different experience across those. But what's been really fascinating about this has been how the size of the company is somewhat immaterial to these pursuits. That the AI efforts are more focused on use case than they are the size of the organization. But whether you exist on multiple or just one of these spots tends to depend upon the size of your organization. So far left-hand side is establishing executive alignment. And I think that's the most meaningful thing that I take away from what I saw happen at Generac. That was successful and is successful because you have executives that care about the initiative and know that this is the future of the business. And they're willing to take steps forward to do it. I saw the exact same thing over at Fox World Travel. Sam, their CIO, entered the first action he did is he had us brief the executive team, president, CFO, COO, VP of sales. We briefed that team. And once that team understood the very nature of what we were doing, they were willing to support the efforts that were cascading from it. So executive alignment is critical. Establishing guardrails, establishing mission, understanding the different tool sets that you might apply. When we talk about commodity versus custom, this will come into play as we talk about like what's happening in the co-pilot space versus what you would build. And that executive alignment lets you move into those group envisioning sessions that Tim talked about. So the group envisioning sessions are really about how do I create a broad intent within my organization that the organization doesn't just feel that ideas are sent to them, but they are participatory in those creation of opportunities and then are working with the team to be part of the solution rather than seeing this coming at them. It's not coming at their job, it's coming with their job. So those use cases move into the evaluation of the scenario and picking one or multiple where you're placing your bets. And those bets can be disruptive moonshots, but you usually need to have some that are incremental, that deliver those wins along the way, that the company sees, this is turning into something. And in between that, sometimes you might POC something. And POCing is like, prove to me this actually works, right? Is this possible? Sometimes we're doing that just like, we're taking like that scenario with the IKEA thing, like, what would ChatGPT 4V actually even do with this? We had a scenario for a customer where they wanted to interpret this code that was written in this, like, it's not even Fortran, it's like some ancient, like,
manufacturing 4GL.
Yeah, it's like, what is this?
Yeah.
And they wanted to turn that into a document. It's like, is this even possible? Like, and we threw a data scientist at it. And we're like, it might be, but it's more like a research project. Like that one, you might not want to throw a lot of money at versus this other one, which is probably a better pick. So you get to that point and you're building out pilots, which are moving into a production state. That's what, Tim went through the process on 3 different scenarios of saying, I'm going to take this, I'm going to get it in front of business users that are using it to do their job. And we start small and we grow. And then we're eventually getting to these production iterations that are building in machine learning operations that Brandon's going to talk a lot about is what are the components that we're building in when this is truly at a phase where it's impacting the business. It needs to run just like any other operational platform. Once it's delivering value, you need to consider it an operational system. And then this last piece is very interesting because scale pattern is really about like, what does this look like when I do a lot of it? And some of the companies we've engaged in, that's one of the first questions they've been asking. Like Johnson Controls, for example, like they're going to do this not once, not 10 times, not 30 times, but hundreds of times. How many bots am I actually building here? How many models am I building? How much am I reusing them, componentizing it, plugging it across multiple platforms? Or is it one bot to rule them all? There's some good answers there. There's some emerging best practices. Feels like some of the other things we did 5 years ago. Very interesting where that comes into the journey, but you have to consider it across the channel. So you're somewhere on this journey right now, and understanding sometimes you need to even back up to go forward. Like if you're here and you haven't really gotten this yet, sometimes you need to back up in order to be in a position where you get the support you need to get the financial backing or the people or the support or the upskilling to be able to move forward. So when you think about executive alignment, you're thinking about what does the business's mission look like through the lens of AI? That's really the question that you're asking yourself. What does my business mission look like through the lens of AI? The question of what is the organization's stance on it? This is an interesting question. Like, actually, we were brought in by a CIO to talk with the CEO about what the organization's stance is. To kind of like educate them about what that stance even is. In the sense that the CIO's question of like, what is the stance was almost like the wrong question to be asking. Because really what the CEO is, he was pretty excited. Like, he just kind of wanted to know, like, how do I guardrail it? How do I set the right framework to be able to put myself in the right position? Positioning the message, the relationship with people. Once you go and you start driving initiatives in this space, people either see it as a threat or an opportunity. How do I make it an opportunity for them? And a lot of that comes from the way you talk about it and the way you engage the people that are part of the solution and help them to see it as part of the solution for their own career. So I was at this, I think I mentioned this the last talk, I was at this Milwaukee Tech like AI group mixer thing that I spoke at briefly. And there's 75 people there. And what I asked the group to say is next time we come back, there should be 3 times as many people here because this is a fraction of the individuals impacted by AI within our professional ecosystem. And now's the time for us to be thinking about this in the context of everyone's work. And then understanding common blockers. So that executive alignment is really about positioning the company. Which leads us to, and this is what I walked through with this CEO, was here are the main blockers that you need to think about as you start walking toward the journey. The first blocker is this concern about data privacy. And this is, in a sense, this is like a little bit of FUD. It's just like anything you put in ChatGPT is becoming used to be able to retrain models. Like, God, watch out. And yes, I mean, it is public once you start putting, like, you shouldn't put the secret sauce of how you produce your product into ChatGPT. Yes, that would be a bad idea. But when people engage in these projects in a professional way, you're using private instances of all of this that isn't shared to produce new versions of models. So just the reassurance that when you go down the path, it doesn't mean that the rest of the world knows your recipe for producing a certain type of rolled alloy or the secret sauce in your type of carbon you're using, or the idea behind like how do I make my boats more efficient than someone else's boats? Like, I'm not sharing that with someone else when I deploy a private instance. So that's I think that's really important. The second is this idea of data not being ready. And we talked about this earlier. This is really more about start with the end in mind. Start with the end in mind. What am I trying to solve? And then what do I need to be able to solve that problem? What needs to be true for me to solve the problem? Don't start with this like my generic data needs to be ready. Start with what needs to be true for me to solve that problem, and then build incrementally from there. And that may mean you don't take the moonshot opportunity quite yet, but it might mean that you incrementally work toward that opportunity by making progress for perfection. Human displacement is a concern. This is more about attitude than it is like the actual thing itself. Disruption of humans has been around forever. This is our opportunity to be able to do it right, to do it in a way that focuses on doing it in a human-centric way. We all care about the people around us. This is our opportunity to be able to force multiply people rather than just force multiply machines. So attitude is important. This is probably the most, if I were to say like data privacy being concern one, concern two is probably this like, what if it gets it wrong thing? And you could ask yourself like, how do I actually really even understand whether it gets it wrong? How do I know if a human gets it wrong? It's probably another question to ask yourself. Like, there's a lot of ways to handle this. This is confidence interval. This is giving them reference to where the document came from. It's highlighting the text the content came from. It's measuring what confidence actually means in this context. Like, what does it mean that it's a 99% confidence interval, like versus a 50%? It's injecting different types of language into the prompts, like don't answer if you don't know, like insert maybe or might, like a human would if it's not sure. Like, what do I do if I don't know, right? I just either say like the way to the bathroom is through there because I know, but like maybe I don't know exactly how to get to like this other business in the office park. I'll be like, it's probably over that way, right? I injected language there that we all understand to say I kind of know and it's directionally that space. We can do the same thing with models, right? Or if I just straight up don't know, I just say I don't know. We need to do the same thing. And then the last is bias, and this is a loaded term. And it's something we need to be very cognizant of when we build these models. In a lot of cases, it's not super relevant, but in many cases, it's extremely relevant because it imparts this need for us to think about who does my AI platform impact? When I think about the end in mind, who is it impacting and how do I avoid the consequences of me designing this in a way that takes advantage of or or unintended consequences that I may need to be projecting? And a lot of that's about like things Brandon will talk about, like not building black box models, like understanding I want to see what's happening inside the machine and be able to understand it, gauge it, measure it, know the output, and think about the data that feeds into the production of it. So these are common things. These are all achievable. These are problems that can be addressed as a component of doing this right. So when we talked about the envisioning group, these can be 5 to 100 plus people. You know, we've all done these both virtually and hybrid. Creating ideas is one of the most empowering things from your teams, especially if you tell them it's going to do something meaningful. Like if it's just ideas for ideas' sake, it's not worth it. If it's ideas because you know you have some acceleration and momentum, it works. So this is just an agenda of what that looks like. There's Tim again. This is one from our on-site there. Tends to be, you know, generally like 3 hours-ish. You start with art of the possible. You get people exposed to what it is. I'm actually fascinated by how many people haven't even used ChatGPT yet. One of the things I learned in this is that sometimes you need to start with just like, here's what ChatGPT is and give people that like light bulb moment of what? Like that's a thing? And then you're like, yeah, that's the thing. It's been a thing. Then there's all the rest of them that are like, yeah, I don't understand that. And then you show them the art of the possible. Then you can break out the groups that can do the ideation and bring them back based upon prompts. And you immediately get hundreds of ideas as a result. And produce something like this, which we showed before. So I'm going to hand over to Brandon. And Brandon's going to start talking about how do we evaluate a scenario and how do we get going with it.
Yeah, thanks, David. So the life cycle of AI projects is, as Nathan pointed out, quite long, but it does have a starting point. And I want to talk about that starting point by explaining why I do what I do. Why do I do data science? Because I think there are a lot of parallels between the two. The world is super interesting, and I think data science applied math is the best way to understand it. You know, why do some countries win more Olympic medals than others? Why do some students drop out of high school and others don't? Why do farmers sell soybeans more on Friday than they do on Monday? Right? All of these questions of causality are typically asked by clients as a starting point for projects. But they're like the least useful to actually answer. And we very rarely do because it gobbles up resources that aren't useful in a predictive system. So starting with the right question is everything. And they often can be why questions, but we don't want to do that. There are two big differences in how data scientists work. The first is explaining stuff, and then the second is predicting stuff. And I think that sort of jangles our intuition a little bit, because it seems counterintuitive that if you can explain something, you couldn't predict that something, right? If you understand it causally, you should be able to use that understanding to make some inference about the future. And for a lot of technical reasons that I'm not going to go into, this is just not true. And a case in point, a CEO of a company that writes software for the commercial real estate industry approached me a couple of years ago, and they said, we need to understand why some of our employees do certain projects faster than others, all else equal. So what's going on here? And so I asked, what you're interested in this for what reasons? And they said, we just want to understand our business better. So, okay, so you have no interest in predicting how long it's going to take somebody to do a job, right? Yeah, of course not. Okay, so we spent a bit of time getting to the bottom of that question, and it involved a lot of like complex charts that really unpacked and disentangled the nuance between variable 1 from variable 2, and like rooted out all of the uncertainty in that question. And they liked it. They loved it. At the end of the presentation, though, they go, great, how well does this predict how long it's going to take somebody to do the job? And I said, well, this model really wasn't built to predict. It was built to explain the phenomenon, right? So the intuition here is that explanatory models explain the past, whereas predictive models, they fill in a blank about the future. They feel very, very similar, but they're not. So how do you prevent asking a sort of useless question? And I don't mean that sort of meanly. I still talk about why questions all the time in my work, because this is just what we do as people. And who cares about the sort of statistical details? But the way you prevent that is by focusing on ROI, right? And there are 3 components to this. There's like the measurable stuff, the things that you can quantify. There's the capability ROI, which is basically how well a project allows you to develop your in-house ability to predict stuff. And then there's the strategic component of ROI, which is if the project positions you to activate your strategy. Different projects have different ROIs. The ones you start with really ought to have measurable impacts, but you can invest in a platform that has a strategic and capability ROI as well. So once you have a sense of the sort of ideas that define the projects you should do, you still need to find them, right? How do you find those things? And the chatbot examples are all the rage because they're super powerful, very useful. But there's a whole family of projects that aren't really chatbot-esque, right? And these are the ones that sort of follow this structure. First of all, they're benchmarkable. They're either benchmarkable because there's an existing solution that exists, right? Some legacy analytics solution that is, suboptimal, or there's a human doing it right now with performance that you can track, and so on. The next thing you want to have is actually it needs to be datable, or there needs to be data for it. And I'm not going to talk about sort of the characteristics of the data other than that it needs to be trusted, it needs to be clean with varying definitions of clean, and needs to be sufficiently big. I don't mean like big data in the sort of marketing term sense. It just needs to there needs to be enough of it, and enough is defined differently for different problems. I think the most important part of these 4 things that sort of allow you to zoom in on a use case is if there are favorable adoption characteristics, right? So the business doesn't have unreasonably high expectations of model performance, right? With the chatbot, I think we all get like it's going to hallucinate or make mistakes. That's an expectation that is okay and tolerable in certain contexts, but in other contexts, little mistakes are super problematic, like in a healthcare setting or something. But there are a number of characteristics about adoptability, basically, that make things more likely to succeed early on, which is the minimum accuracy characteristics, the evaluation window, or the sort of period after the pilot or POC ends, during which you sort of, kick the tires. Is this thing any good? Is it actually working? That should be short, hopefully under a month. That's because people have really short attention spans and they kind of move on to bigger and better things. So you want to capture attention quickly. And then hopefully it's not disruptive to people, process, or tech. And this might fly in the face of the two innovation paradigms that Nathan talked about before, the incremental versus disruptive. But it doesn't. This is just about picking the problems well early on in your journey so that you sort of don't throw the baby out with the bathwater, right? You want people to be interested and invest in their machine learning programs. So just pick the ones that aren't going to require a ton of investment in change management. Okay, so that's sort of the foundation. Brian is going to talk a little bit about a pilot that we did to kind of click into some of these details.
Guess I'll take the magic wand. So POC versus pilot. Do you want to talk about that before we jump into what a pilot really means?
I do, but not.
Yeah, you want to talk about that?
Yeah,
okay. All right. So a lot of times when people start this journey, we can often come to the table and do a demonstration for you, even with your data. I had a customer that sent me over like 5 contracts. What can you do with this? And I spent like 2 hours and threw up a ChatGPT, and they asked questions of these contracts and like, wow, that's really cool. But it's never that easy. Like you can get something out of it like pretty quickly, but there's always a little bit more that meets the eye. So I want to walk through some of those challenges that actually come up. We talked a little bit about the Generac. We talked a lot about Generac actually today, and Tim was here. So when we got into the Generac solution, what we did is we kind of identified what are the outcomes that we want to get out of this. What are some of the challenges this is going to solve, and how are we going to get here? What's that journey look like for us? We worked with Microsoft on this. This is from a case study that Microsoft did with them. And what we did is we started to break this down. What does this chatbot look like? What does it need to do? So I think Brandon kind of mentioned, like, what is the end result? We started there. So good components for a technical chatbot are going to have obviously some sort of language, interaction with the users. So support for, how am I going to query it? It's ad hoc. I don't know what's going into this thing. It's going to be 62 people from customer service that are going to be throwing stuff at it. We have to be able to support any kind of these requests. We have a response that has to come out of this. This is, the information that the user's asking for. And then we decided that we want to give them the source of this information. This goes back to kind of the Brunswick example that I talked about, where 70% isn't good enough. It's got to be like 99% when you're saying cut the fuel down, right? So, and then the last thing that's really super important, especially with Generac, was just the feedback mechanism. And it's simple. It's just thumbs up and thumbs down. So those are the 4 components that you're going to need to get out of that. And ChatGPT it only does this one right here, right? So we've got to do a lot of work to get the input in. We have to figure out how to get these sources back to the user, and ChatGPT doesn't really care about, whether they got the answer right or not. And it's just a bunch of words that it threw back at you. The other thing too is like, what's the information that we're feeding? Most companies have product manuals when they're, selling a product, and their product manual might look like this. A lot of pictures. The IKEA example is a really good one where here's a step-by-step guide, and it doesn't matter what language it's in, everybody's going to understand it. Take this screw, here's a tool, put it together, 1, 2, 3. But if I'm going to build out, like if I want to answer the question, what tools do I need in order to install this window? You and I can look at this and it seems pretty intuitive what we're going to get at. But if you look over on the right side, that's what these OCR technologies see. And it's all the imagery is gone, all the lines, all the context, all the boxes. It doesn't know what those words mean or that they're related to, pictures of a drill or something like that. So you have to figure out how to break that information down and index it and categorize it in a way that ChatGPT or these OpenAI, these LLMs can actually interpret the information. And then, we saw this example. It's getting better. This multimodal capability is only being pieced together within the last few days. I mean, the technologies behind it had existed before, but not in an LLM capacity. So for years, we've been able to take images and throw them at models and have it describe things to us, right? What is this thing? And it's typically like object detection. So kind of going back to, the previous slide here, like we can have this image broken down and say that this is a drill. But in the context of this document, like putting those pieces together, it's not there yet. We're starting to get there, and I don't even know how it's going to work yet because we've only had like 2 days to play with it, but it's pretty incredible is what it amounts to. So there's going to be new ways for us to solve this, as we go through this journey, but these tools don't exist. Some of the problems that you're going to run into, those tools don't exist yet, and we're going to have to work to figure out those gaps. So now we've got processing information. I know what the result's going to be. How do I actually build a system like this, component by component? So am I going to walk you through this diagram? Feel free to take some pictures. But at the end of the day, I've got to have a data pipeline. I have to get that information. I have to process it. I have to be able to take, another common thing that customers come with us is that their documents are versioned. So, I might have a new technical document that comes out like every month and with certain updates to it. I have to be able to push that information into my models on a regular basis. And I can't have people like copy and pasting and managing that information. So being able to create a data pipeline to flow that information in the system is important. And then everything else here is, just what you kind of expect, right? I've got my language model, decomposition. It's going to attack that problem. It's going to provide the result. But as you can see, it's busy. There's a lot of different components that go into it. And then the last part is just being able to monitor. And this is something that most people have overlooked when we do projects with them, is that getting a feedback mechanism. So how do I know if this is good enough? And it doesn't have to be complex. I don't want people to overthink it. I would suggest just starting with that, thumbs up, thumbs down. Did I get close? Did I not? And that's going to give you directionally if this is going to work for your organization or not. And to Brandon's point, like do these evaluations on a frequent basis, like a month, make an iteration, another month, and then you can get ready to go to like a production setting.
Yeah, it's a great point. So let's keep popping the hood. Let's see what else is like under the surface of one of these systems. Before I do, how many of you have or know if your company has experimented with data science, machine learning, but haven't gone to production? Yeah. Okay, maybe about 20% of the group. How many have gone to production with a model? Okay, possibly a larger group. Okay, so how do we get there? A lot of people think that a machine learning system looks like this. There's some machine learning code. This is excellent. Okay, we're done. But the reality is a little more complicated. There's a lot more going on, and in fact, machine learning component is the smallest component typically of a system, especially robust in production systems. There's serving infrastructure without which you can't serve model output to the business. There's feature engineering, without which the model doesn't really have anything to learn from. There's monitoring, without which it's very hard to debug, which is problematic in regulated spaces. If you're a model risk management group at a credit union, you care very much about monitoring your models. There's a lot more going on. And if this sounds like a lot, it can be, which is why it's important to phase when you build each component. And you do this so that you de-risk the project. A lot of executives will think of data science as a science experiment, and that's true until it's not, right? Machine learning engineering is engineering, but before it is, there's a lot of sort of uncertain science-esque elements to it, which are very risky and sort of unwanted for a business who's trying to maximize investment in their programs. So isolate the sciencey parts from the engineering parts by doing something like this, typically in 3 phases. The first of which is a POC, which, as Ryan was sort of nodding to, is a little different from a pilot. The difference, there's a difference, and it's not without distinction. The POC is all about proving that business value can be created from the models. It's really not something technically, like can this technically be done? It's, I guess that's not always true. There are some times where you're trying to prove that something can be technically done, but the vast majority of times, you're just trying to prove that business value can be captured. And if your data science team is not focused on this, then they probably are accountable for the wrong things. They should be accountable for business goals, not technical ones. The field has evolved to a point where we kind of have a sense of what techniques are going to work in what use cases. And so unless you're doing something extremely novel in a very narrow band of the world, you should know sort of what to invest in and what not to invest in. But anyways, this POC phase is really 4 things that can be customized to some extent, but you pretty much always want to do the data collection, of course, machine learning, like the code, which you need to involve feature engineering for, and then model validation. This is the part of the project where you're basically making sure that the model is producing reasonable results given whatever constraints you have. And you want to test this with business users typically. Hey, does this look good or not? I built the product recommendation engine for Publix, the sort of Florida-based grocery store, before I got to consulting. And the model validation phase of that project was very interesting because as a product, you go to Publix.com, you throw some stuff into your grocery cart, and the thing I built will recommend complementary stuff like Amazon. It's nothing fancy, but they were trying to validate the model by basically confirming that the model was producing intuitive recommendations, right? You put peanut butter in your cart, you want jelly. You buy a ham, you put ham in there, you want cheese of a certain kind, right? Very simple stuff. That can be confirmed with users, but there is another function to product recommendation engines, which is to help your users explore your product universe, right? Well, what if, like if you're Netflix, for example, right? You want your users to find new content so you continue to pay the monthly subscription. So model validation has a lot of flavors to it, is my point. But once that is done, you've confirmed that you can create business value. Let's move into actually sort of capturing that business value, right? It can't be done. Let's actually go do it. And that's where you move into the MVP, which is basically the POC, but with some surrogate infrastructure. And then you're also doing more robust testing, debugging, and some configuration and so on, because you don't want to be, you're basically trying to de-risk, right? But you don't want to do so much de-risking that you gobble up lots of resources that could be otherwise spent better later on. Okay, so later on, after some conditions are met by the business, right? It's like, okay, this thing is running well, that's great. Let's move into the last phase, MLOps, right? This is essentially about automation. There's more to it than that, but let's automate what we have. Let's make sure that it's reliable, logging's in place, etc. Okay, so this is the same information, just presented differently. And I'm not going to drain this whole slide because there's too much here, but this basically just defines and explains the so what behind each of these components, and then when to do each. You can customize what components in the blue you do during each phase, right? You don't. We have some clients who, for example, know they want to go to production right away. Maybe that's because they've done some of their own research. They've tested a model. Hey, this is good enough. Can we just deploy this thing? And that's totally reasonable. We've worked with a pathology diagnostics lab that was very interested in basically making their revenue cycle management team, the people who are responsible for collecting the accounts receivable from insurance companies who are reluctant to pay the claims. They wanted to make that team more efficient. Their team had too many claims to get through. So when the insurance company denied them, they really had to be smart about picking the claims that they thought were most likely to be paid out at the highest contracted amount in the shortest amount of time, given the least effort, right? So there's a lot of little optimization things that they were interested in. But they had an economist on staff who had sort of investigated this. He just didn't know how to move it to production. So they hired us and said, just move it to production. Well, there was a number of things that weren't really done to allow that model that was investigated on the side to be successful in production. So we ended up sort of doing the whole thing from the get-go while sort of learning from what they had done prior. My point is, you don't have to do this always. It's not totally prescriptive, but it's a really good place to start. Does anybody have any questions about this? Okay, so there's the double-click slide. So this is basically the POC components, data collection, feature engineering, ML development, and then the model validation with some concrete examples to kind of put boots on the ground a bit. Again, I'm not going to drain this whole slide because there's a lot here, but these are the things I would start with, right? It would be hard to do a POC without doing any four of these components. Sometimes you see people skipping the model validation phase, and that what happens then, I don't know if anybody has experience with this. Does anybody have experience with this? Yeah. So basically, people don't use it, they don't trust it, which is problematic. But this is the thing that is skipped the most, and this goes back to what we were talking about with explainability and making sure that it's not a black box. You have to do this, right? Going back to the story I shared before about the CEO asking us why some employees work faster than others, that project was exclusively about transparency. Why do some people do what they do? Why are there particular outputs given particular inputs? This is like the whole point. And some people don't prioritize that, or they prioritize it at the expense of prediction, like I mentioned. Okay. Does anybody have any questions on this? And you'll have access to this all afterwards, so you can take a look at the examples and so on. Okay, so you build the POC, and then you stack on like these 4 additional components. Typically, the most important one is serving infrastructure. That's just surfacing the model output to the business. It could be an endpoint. It could be you're tabling data somewhere that is referenced in a report. It could be, this includes things even on the front end, right? Like, so when I mean infrastructure, I don't just mean backend. It could be the UI that they're using and so on. Testing and debugging, super important. Don't really need to talk about it. Data verification, also something that's skipped a lot. If there are any data engineers in the group, you might feel the pain of skipping this one. And then process management, again, super important, but orchestrating all these jobs and so on is super important and kind of the core value add of an MLOps framework. But this is an MVP, this is an MLOps, so what's going on? Again, you can customize. MLOps, this is really just shorthand for like automation, right? So there's actual automation, making sure that tasks, which in a POC are usually manual because you don't want to prematurely optimize, and monitoring, configuration, resource management, and metadata management. Each of these topics could warrant like a 20-minute talk on it, so I'm not going to drain this, but if anybody has any questions about sort of the nuance of it, probably let's talk afterwards. I think it's an interesting conversation. Okay, so done the POC, there's business value that can be extracted. You've deployed a minimal viable product, so you're making sure that you can actually capture it. And then you've automated it, but you're going to do this a lot more, right? You're going to do this at scale. So how do you ensure best practice? How do you enforce certain policies, and so on as your data science and machine learning team grows? You should stand up a center of excellence. So all that is really doing two things. It's enabling positive things and enforcing that certain best practices are met. The most important things that I've noticed that should be enabled are this sort of curiosity-driven exploration. There are very few examples of building something that was sort of top-down led. Before I got into consulting. In consulting, it's a little bit different, but in industry, when you're a data scientist, all of your projects are sort of all the valuable ones, at least in my opinion, the ones that turned out to be valuable. I don't have a real horse in the race. Tended to be ones that the team thought of when they made an interesting observation. They go, huh, that's kind of curious. Why is that the way that it is? Those are not sort of top down. So it's really important to allow the team to explore their curiosities. This is not the same as open-ended research, though. I think that's sort of the tension. You'll hear executives say, this isn't school, this isn't academia, you're not publishing papers. This is about sort of getting more business value. And they're not actually they're not in competition with one another. The next thing you want to enable is very easy, very cheap access to subject matter experts who know the business the best, right? Data science doesn't happen in a vacuum. You need to know people who can explain the data, the business process behind it. But these might seem really obvious, but avoiding or not focusing on them does have sort of unwanted outcomes. The next thing you want to enable is data access. I mentioned before my time at Publix, and as a senior data scientist without access to data. This was a problem for obvious reasons. They were really early in their journey, and so basically I was relying on CSV sentence, right? Which is great for POC testing, but when you go to production, there's some issues there. So you want to enable data access and compute access, obviously with some policies in place. Otherwise, you can really run up your cloud computing costs. But you don't want to give somebody access to 14 gigabytes of RAM when they're trying to train a very large sort of data greedy model. Just sort of silly. Now, you do want to enable failure. And this is just like the fail fast kind of notion. And not just tolerate it, but encourage it, enable that to happen. And that's really what an MLOps framework is about. It's about competing on the process by which you go to production. Not really competing on data or models anymore, but the process behind those things. So the story here is make all of this cheaper, and then you need to balance that with some rules. And you want to put rules around the budget. You do want to put some rules around data access. They shouldn't have keys to the whole castle, just the relevant rooms that there might be interesting things inside of. And then enforce alignment. And this is the alignment that Nathan was talking about earlier, the executive alignment, right? Making sure that people are not just in support of the projects, but real champions like Tim was talking about, right? You can't have somebody just be like, yeah, thumbs up, do this thing. And then when, things go a little sideways, they go, whoa, they kind of back away. You want somebody to champion these things. Okay, so how do you sort of go from the curiosity-led development to business impact-led development? And there isn't really anything explicit here. Your data scientists will do it for you. They'll, amongst themselves, talk about, they'll make very uncertain things, right? We don't know if we can do this particular technique and arrive at this particular outcome, but they'll investigate that on their own before they go talk to their manager or whatever. And then by the time they confirm that, then they'll stop talking so uncertainly, and they'll transition from that sort of curiosity thing to an impact statement. They'll say, well, if we can incorporate this thing, then we'll arrive at these expected results. And we know this because we've done back testing. And it will happen naturally. It doesn't actually need to be enforced. So whole point of a COE is to do better work faster without any extra risk. I think that's fairly obvious. But the really unobvious things, I'm not necessarily going to talk about the organizational aspects, the team structure aspects of a COE, which is a super, super important part, but it's very subjective, and I don't want to get too prescriptive on people. We can talk afterwards about my sort of recommendations, but the things that I can talk about are related to these ideas. When and where do you enable, and when and where do you enforce? Again, this is super, there's a lot of nuance here, but typically you want to enable in the top two phases, in the POC and MLP. Get through those cycles super fast, have an idea, test it, does it work, does it not? If it does, let's deploy it. And then you have to enforce some stuff. So that's when you're down in the MLOps phase. This is for simplicity, but you can obviously, you have to enforce compute and data access up in the POC phase. But in general, this is really where enablement is the most important. And in general, this is really where enforcing is the most important. Does anybody have any questions about this? And these do look like Packer colors up here. Brian and I, when we were playing with these slides, I've said this is orange. It is not orange. We'll see. All right, so the minimum components, we talked a lot about the components before, but to sort of simplify things, you have a sandbox, right? This is where you're sort of experimenting. And there are really kind of two sort of prongs to experimentation. There's the sort of A/B testing experimentation where you're like, you know, does the blue widget or the red widget make higher conversions, right? There's that kind of thing, which doesn't happen in a sandbox. But this kind of experimentation, this is sort of like the R&D, this is the curiosity-led development. Hey, I noticed like this weird spike in sales at this time. I wonder what's going on there. Let's investigate it. I wonder if we can extract some information from a data set that's currently being missed and incorporate that into our demand planning models. That kind of thing happens all in the sandbox. Then you move into the pilot MVP. Here we sort of smash those two words together, pilot and MVP, implying that they're essentially the same, right? When you're piloting something, it's in the air, right? It's not just on the ground in sand. And that really is a distinction with a difference, but it does depend on how you define it, I suppose. And then you move into production, which is about reusability, reliability, and simplicity, the MLOps things. And then you have this thing all the way to the right, which is sort of a specialized area for basically our exceptions to everything that I've said so far. Sort of uncommon, but does happen in certain scenarios. Yeah, especially with like, you know, if there are very special privacy concerns and so on. All of these components are on a sort of foundation of solid ethics and a good data platform. The ethics is a whole topic unto itself, but just to comment briefly on it, a lot of people will say you need to have an ethics committee to get started with data science, and that's only true sometimes. Certainly not true all the time. Just depends on the use case, right? So another thing to point out with this is sometimes it actually matters when it seems like it shouldn't. So the example before of that diagnostics, that technology lab, where they're basically just taking a health insurance claim, they're making the health insurance claim and they're submitting it to the insurance company. They get paid from the insurance company if that claim satisfies like the contract they have between the patient and the insurer. Some of those get denied, and the model that we built will basically take that pile of denied claims and just rank them. Give me the best ones on top, the things that are going to pay out the most, and then the ones that are less likely to be approved and pay out lesser amounts, put them on the bottom. It wouldn't really seem like you would need an ethics committee to review the model in that sense, but you could if the output of that model affects the way that that lab does business with their customers, right? What if management finds out like, well, hey, you know, patients of a certain demographic tend to be approved more, so why don't we just accept those patients, right? That seems problematic. It seems like somebody should sort of make ethical judgments about that. So my point with that is sometimes you need it when it might not really seem like you do. And in cases where it seems like you do, maybe you don't. There's this general scaled architecture. Does Nathan want to talk about this?
Sure. So one of the common questions that we get, well, common is probably overstated. One of the questions that we get from larger enterprises is what I had talked about earlier, which is, am I building 100 different models, or am I building one, or am I building some collection of that in between? And I think it's important to note that this is not really a solved problem at the moment. 5 years ago, maybe even longer than that, we were getting started in helping companies were getting started in deploying their cloud environments, their Azure governed environments. And we had established practices that were better practices for doing that. And in fact, we helped write the best practices for a lot of those things. But there wasn't like a framework defined as to like how you make those decisions. And over time, established frameworks have come out from Microsoft, AWS, Google, in terms of like, here's the pattern that better companies are using, and they call it the cloud adoption framework, in terms of like, how should I position my subscriptions? How should I label it? What should I use for classification? All these things kind of become best practices that you have to have really good reason to diverge from. At the moment, this is sort of in a better practices zone, right? Of like, what are we learning? What is someone else learning about the same space? And what I've sort of leaned on to answer this question, or at least point in the right direction, has been the two tension forces that exist in how you answer it. Who's familiar with the like jobs to be done framework? Okay, very, very few, if any. Okay, so the jobs to be done framework is at the top of the thing. It's the why. It's the, I am building I have a hammer because I need to put in a nail, right? But the guy doesn't actually want the hammer. He doesn't want the nail. He just wants to fasten two things together so they don't become unfastened because he's building something. So the why is the fastening, and it may even be the building he's building. So the jobs to be done is ultimately what you're serving through the mission of your organization. So you can start thinking about this in the context of the scaled architecture in terms of this like top-down framework. Sometimes people think of it like as customer 360. It's like another way to think about that. Like, what are all the pieces I need to put together to position a view for my customers that feed from data across the business from different domains? Okay, so that's like angle one. Angle two is the idea of data domains. Who's familiar with the data mesh architecture? Okay, data mesh architectures are built around the idea of data domains that are aligned to areas of the business, or vertical stacks of things that you're building within the organization that isolate data into groups of stakeholders that have autonomy around that data. And that doesn't always align to the job to be done. Okay, so like the thing you're doing from the customer, which spans across data domains, doesn't actually always align to the functional delineation of groups within the organization. They're in the problem, right? And in between those two pieces is models that you've built based on data that sometimes are combined together to serve a specific use case. So this problem is more complex than it seems. And again, it's like the ethics problem is probably a talk in and of itself, which is a good idea for a future talk. But it's when you look at this idea, you have to think about it in the context of both of those sort of pulling extremes and how they relate to how you build reusability within the overall spectrum. And that reusability may be the interface. Maybe that's the reusable thing. And maybe you have domain-specific AI models, or maybe you have domain-specific AI models that actually serve multiple use cases, and then you have an API that talks between them. Or maybe they're even having same service domains that are reusable. All of these are kind of modular components that we need to think about at scale. So I'll kind of cap it there, but understand that this isn't a solved problem, but it's a problem that there are other frameworks that we can apply to the problem to help us to position ourselves to be more flexible for when the day comes that it actually is a solved problem. We can skip. Oh yeah, go ahead.
So this is very similar to what Nathan was talking about. This is a sort of a simplified version of an MLOps architecture, right? So sort of the big rectangle in the middle, this is really the whole machine learning lifecycle, right? You're going to do some experiments, train a model, get some results, maybe package them into modular components, right? If maybe you have a data domain that's similar that Nathan was talking about, deploy and then of course monitor. This is all happening in a CI/CD framework, promoting data and objects between environments and so on. This is kind of just a caricature. So to double click on it, there's this, and just in the interest of time, I'm not going to drain this slide either. But I guess one of the big takeaways of this slide is there are so many different iterations of this framework that you could use depending on different data sets, right? So this is sort of for a classic tabular setting where you're doing demand planning, or the sort of pathology example I gave before, anything where you have a tabular data set. This will look different if you have text data, which is really, really popular right now, unstructured data, or computer vision models, but they do follow something very similar. And there's a lot more information that we can share if you're interested in learning more. I can point you to resources or elaborate on any of these points if you're interested. And with that, I want to close just on a few prescriptive thoughts on culture. I said I wasn't going to talk about it, but just a few things that I've noticed. So like curiosity drive, I've talked about that before. If you do that, you're going to sort of encourage people to learn by doing things rather than just by talking about them, which I think is very important in a climate of AI hype, right? Well, let's actually put boots on the ground and do the thing. You do want to balance short and long-term costs and benefits, obviously, and I still have this as a point because I think sometimes it's lost on folks who are or who hear about projects where the engineering and science parts are sort of meshed and they shouldn't be yet. But if you sort of separate them, then you can ensure short-term gains while still shooting at for a North Star of long-term gains as well. You should have a culture that has a very high tolerance for ambiguity, especially with some of these machine learning projects, where you don't really know if the thing is going to work, or maybe the data set that use case requires hasn't been used before, and there's not great documentation on it. There aren't really people around who seem to know much about it, so there's a ton of ambiguity, and being able to sort of enjoy and thrive on that is really important culturally. And this is probably the most contentious thing on here. I don't recommend having data science be a support team. I think that's fine if you want to focus on incremental gains that Nathan was pointing out. But if you really want disruptive stuff, let people's curiosity drive that, make them responsible for business goals, and they'll do great things. In every organization, in every high-performing organization I've worked for, this was the case. The opposite was not true. Okay, so this is what I said before. You want to encourage exploration, but not open-ended research, just to prevent sort of throwing money down rabbit holes that don't really go anywhere. And if you don't, people are going to do it anyways. I'm a very hard person to manage, I think, and when I've been told not to do things, I do it anyway because I think there's promise there. And there have been very few times where that hasn't really been the case. So it's very important to encourage exploration, but not open-ended research. Okay, non-obvious tips. The companies who are most successful with their machine learning programs are the ones who have committed to it, irrespective of the outcome of any individual project. They're not using this pilot project as a litmus test. They're like, this is just the first of many subsequent projects. Let's do it. And I think that is something to kind of take away from this. So on the macro level, investing in machine learning is important, but on the micro level, at the data scientist level, try to avoid it. There's just a lot of overhead involved with maintaining such a system. Deterministic things are much different from the probabilistic systems that we build. And from the nods in the audience, I'm sure people have very relatable stories to this. Start small and precisely, right? You can't really just say, let's do AI and throw some data at it and you'll have a great use case. Really spend time doing a lot more thinking than doing, at least at the get-go. That's super important for success. And then solve a real problem. I'm not trying to be coy with this. I see, you'd be surprised by how many times people, think they're solving a real problem, but you talk to somebody else and it's not, right? And I think that's probably just a communication thing, not necessarily anything deeper than that. People just need to have access to all the information from a number of different lanes to identify the quote unquote real problems. And if you don't have quick wins early on, you're going to be defunded. It happens. So that's something to look out for. And this machine learning isn't really a science experiment anymore. It's just product development. And I think this is the hardest thing for people I've worked with to accept, right? This is just sort of, it's table stakes now. So it's important too. And then because we're in a climate of AI hype, I should point out that machine learning projects onto themselves are not objectives. They're just a means to an end. So treat them that way. And that's probably more for the technical minded people in the audience who have get super committed to their technical thing that they built and have a problem sort of giving it up and being like, well, this isn't good enough. We have to do something else. And they're sort of upset. They're just a means to an end. And with that, we will end where we started and share the journey. So we can help you at any stage. This is something that everybody goes through in their own way, but there are common themes to what we've noticed lead to success. So happy to help at any time. And with that, I think I'm between you and lunch. So, do you have any other